Anyone can build this project, and I'm going to show you exactly how to do it. This project allows us to create noise based on an object's distance. So we can make something as simple as a proximity alarm, or something as creative as an air piano. For this project, we need an Arduino, a distance sensor, an active buzzer, a passive buzzer, about 20 jumper wires, 3 1000 ohm resistors, 3 different color LEDs, and a breadboard. Start by printing out your hookup diagram. Head to github.com/tsjelectronics. Once you're there, scroll down to repositories, click distance sensor project. This page has all of the important information for our project. We have our code, list of materials, hookup diagram, and schematics. Click the page labeled hookup diagram and print. Our hookup diagram shows our breadboard and where every component should be placed. The colored lines indicate every connection we're going to make with our jumper wire. First, we're going to place all of our components onto our breadboard, and then we're going to make the connections with our jumper wires. First, let's place our distance sensor. Look at your hookup diagram and try to place the distance sensor in the same spot on your breadboard as it shows in the hookup diagram. Next is our LEDs. Something important to note about LEDs is that LEDs have polarity. That means that they have a positive and a negative lead. Our LEDs have a long positive leg and a short negative leg. Give the long positive leg a little outward bend so that it's easier to distinguish from the negative leg. Then pop it into our breadboard. Do this for all 3 of our LEDs and make sure that the positive leg is facing the left-hand side of the breadboard. Our last component is our active buzzer. Just like the LED, this component has polarity, meaning it has a positive and negative lead. The positive lead can be identified either by a marking on the top or a longer leg length of the lead. Place your buzzer into your breadboard using the hookup diagram, and then we're done. Oops, almost forgot the resistors. Bend each resistor into a U shape and place the resistor into the breadboard. Following our hookup diagram, one leg of the resistor should be in the same column as the negative lead of the LED, and the other leg of the resistor should be on the ground plane row, second from the bottom. Okay, our project is half done. Now we just need to make our connections. First, we're going to start with our power connections. On our Arduino, there are some pins labeled ground and 5 volts. These are our ground and voltage sources. Connect the 5V pin of our Arduino to the voltage source line of our breadboard. The voltage source line is the entire first row of holes. These are all connected underneath the breadboard and will provide power source for our ultrasonic sensor. After we make the connection, go ahead and put a scribble through the 5V line. This helps me keep track of which connections I have made. Next, take a jumper wire and connect the ground pin of the Arduino to the ground plane of our breadboard. The ground plane is the row directly above the voltage source plane. The ground plane provides a ground return for all of our components. Now let's make the